Okay, what I'd like to look at now is adding and subtracting rational expressions. Okay, this is adding one fractional expression to another. To give us sort of a guide for this process, what I'd like to do is look at kind of the analog in the real number case of adding two fractions. Okay. And I know everyone here can add two fractions together, but this is going to give us a motivation and a guide for where we want to go with the actual rational expressions. So let's look at adding the fraction 3/4 to the fraction 1/3. Okay. Well, remember the process for adding two fractions together. First, you must write them in terms of the common denominator, the least common denominator, and then simply add the two numerators together. So first of all, we need to identify the common denominator. Maybe off to the side, I just identify for myself that the common denominator is 12. Okay, so 4 is one of the factors of the common denominator. Well, what other factors are necessary in order for their product to be the entire common denominator of 12? Well, 4 is missing the factor 3. So what am I going to do? I'm going to take my fraction 3/4 and I'm going to multiply it by all the missing factors over themselves. That is 3 over 3. 3 times 4 will give me the common denominator of 12, and 3 divided by 3 is 1, so I'm not actually changing this expression. That's the process of converting from one denominator to another. Likewise, we're going to multiply 1/3 then by 4 over 4. Doing this multiplication, gives us 9/12 and 4/12. And now that we've written the two fractions in terms of a common denominator, we can simply add their numerators. Now in this case, we can continue to simplify this. We can add these like terms to give me 13/12. Now I don't think I've done anything very profound here. We just added two fractions, but that's going to give us our motivation for adding two rational expressions. Let's look at this example here. Let's go ahead and add the two rational expressions. 2x plus 2 over the denominator, x squared plus 7x plus 10. And I'm going to add this to the expression 9 over x squared plus 8x plus 15. Okay. Now in this case, we've got two rational expressions. If I already had like denominators, which I do not, I could simply add the two numerators together. But I don't have like denominators, so I need to write both these expressions in terms of their common denominator. Well, what is the common denominator? It's difficult to tell. Why? Because the denominators are currently written in expanded form. It's easier to identify the common denominator when the fractions are written in factored form. So I'm going to go ahead and factor the denominators. At the same time, I'm going to go ahead and factor the numerators, because you never know, it may be that we could cancel out like factors and simplify the problem. In this case, we won't be able to, but just as a habit, I will factor the numerators as well. Okay. The denominator of the first rational expression factors to be x plus 2 times x plus 5. Okay. The denominator of the second rational expression factors to be x plus 3 times x plus 5. Okay. Now I've written the denominators in factored form, and from here it's possible to identify the common denominator. Okay, so off to the side I'll just make note of what that common denominator is. In this case, the common denominator is x plus 2 times x plus 5 times x plus 3. screen this over here, give us a little more room for writing. Well, now we want to write each of these fractions in terms of that common denominator. So for the first expression, now a lot of times students will shortcut this step. They won't write it, and that's okay, but it's important to see all the work and practice it a couple of times through. So here's my first rational expression. I want to write the denominator in terms of this common denominator. Well, what factors am I missing from it? I have the x plus 2 factor, and I have the x plus 5 factor, but I'm missing the x plus 3 factor, so I'm going to multiply this by x plus 3 over x plus 3. Okay. For my second fraction, again, I'm trying to write the denominator of this second fraction in terms of my common denominator, and I see that I'm missing the factor x plus 2. So I'm going to multiply this by x plus 2 over itself. Okay, hopefully we've got a little more room now. So foiling out the numerator, be very careful doing this. Let's go ahead and distribute that 2x, or that 2 through. And distributing the 9 across. Now be careful doing that. Notice that it's as if there were parentheses around this x plus 2. Okay, continuing to FOIL out the numerator of that leftmost term gives us 2x squared plus 6x plus 2x, or plus 8x total, plus 6 all over x plus 2 times x plus 3 times x plus 5. Okay. Now that we've written both these rational expressions in terms of like denominators, we can simply add their numerators. 2x squared plus 17x plus 24 all over that common denominator. Now what I need to do is to double check to see whether or not this attempting to factor it, though we find that the numerator does not factor further. If it did, we would go ahead and factor it, and then there would be the possibility that factors in the numerator would cancel with those in the denominator. But in this case it doesn't. So we've gone ahead and simplified these two rational expressions by adding them together. The process involved finding the common denominator, writing both in terms of that common denominator, then adding the numerators together, putting the fraction over that common denominator. Once we'd finished that, we checked our work to see whether or not it was possible to further reduce down the fraction.